I'm Marc Goldman with Esri. I'll do a little bit of intro in a moment here. We've got a great session set up. I have met with our panelists, have talked to them, have looked at their slides and their content. Some of them I've known for some time, and I know that we've got a great session here. We will go through intros later, but I just want to let you know that we've got, like I said, a great panel. Once I get through my content, I'm going to give a little bit of an introduction on myself as well, but between Paul, Ignacy, David, and Louis, we are guaranteed to fill your head with some amazing information about the world of BIM, in my case, the world of GIS and BIM. We'll have Paul Doherty talking about BIM and smart cities. Ignacy also talking GIS and BIM, a term Geo Bim that I'll also refer to in a little bit different context. A little bit later, David Moreno from Barillion BIM, talking about BIM in Spain. I've seen some of his content, some great project examples. And then finally, Louis Watts from Autodesk. He and I spoke last night, and he's doing some wonderful things around the area of aviation. You know, airports are essentially cities unto themselves, and their use of BIM and GIS, in fact, is quite unique. So, my topic is about location. It's something that, we don't necessarily think about immediately in AEC. When we're working on architecture, engineering, construction projects, the importance of the location sometimes is secondary, although it really should be front of mind. Location, it's everywhere, and I think it's everything. A little bit about myself. I've been in the construction technology industry perhaps since its inception, although this is not a picture of me. It is around the time that I was born, actually. That is Ivan Sutherland, who is, amongst other things, known to be the first creator of a CAD system. What he's got on his screen there is an application called Sketchpad from 1962, where you can see he's sketching out with a stylus on a screen, what looks to be a chair, if you can zoom in on that. That was about the time I was born, actually. Over the last couple of decades, 3 decades, I've been involved with, like I said, the construction technology industry. Worked at Autodesk twice. My first tour of duty, like I say, it was back in the late 90s, early 2000s, working on some of the earliest versions of AutoCAD, 3D Studio, Animator Pro, various other applications. Over the years, I went back to Autodesk and worked on some of the early versions of Revit once Autodesk acquired it, integrating it with other applications, sort of the early days of BIM. And these days at Esri, who is the leader in geographic information systems, I'm bringing together GIS and BIM. And I'm absolutely like a kid in a candy store, seeing the capabilities of Esri software combined with the tools and technologies and workflows that I've come to know over the last couple of decades. So I'm going to assume that maybe half of you might know who Esri is. Like I mentioned, we are the founders of the world of GIS, Geographic Information Systems. Best known as digital mapping, but it's much, much more than that. Our ability to analyze geographic information, bring together architecture, engineering, construction information, the visualization of that data, the analysis of it, the ability to tap into our tools through our APIs, through our SDKs, full development kit. You'll see some of the capabilities expressed through my presentation here. I'm going to go over a number of demos, examples, customer case studies very quickly. I've maybe have about 10 or 15 little 1-minute videos that I'll talk through once we kind of jump into this. The concept that we talk about at Esri is this idea of a geographic approach, putting location really at the center of your mindset as you're working on infrastructure projects. The idea of a geographic approach, it's the modeling, it's the, put my glasses on. It's putting together the various layers of information, again, with location being a key element. Let me try this again here. No, not going to work. Okay. Using that location data, spatially analyzing it. Data science is around spatial information, allowing you to understand the entire infrastructure cycle, again, with location at the core. Infrastructure management, that's pretty well understood, I would assume, by this audience. It's the entire life cycle. Beginning in planning, going into design, obviously the construction, the delivery of the project itself, but ongoing into operations, asset management, facilities management, is what infrastructure management is. And why we're talking about it, is kind of obvious. Our need for improved infrastructure is global. Our ability to deliver what we need infrastructure-wise is perhaps questionable. What you're seeing on the screen here, on the green bars, are the expectations of the G20 nations to dedicate their GDP, their income, the country's income, to infrastructure. And you'll see on the right side there the gap between what is needed of those G20 nations and the actual delivery that is expected. So we've got a big gap across the globe in our ability to deliver the infrastructure that we need to meet our growing population, to meet the needs of the world who are moving from rural to cities. And we either need to be better at what we do, or we need to increase the funds that we're going to dedicate to infrastructure simply to support ourselves as the world is growing. So just to kind of jump into the weeds here, what are we doing at Esri, and what are we doing specifically with Autodesk, who we have a very strong partnership right now to work better, to evolve the world of infrastructure, to be more productive, to be more collaborative, to be more informed. So I'm not going to talk through each one of these boxes here, but what you're seeing is our connection with Autodesk software, ours being Esri's software. Esri develops Arcgis, desktop, cloud-based, enterprise, and cloud-hosted solutions for bringing various layers of information together, including your CAD, your BIM, your infrastructure information. We've made direct connections with Civil 3D, with Revit, with InfraWorks, with Autodesk Construction Cloud, so that the information that you might create in your BIM and CAD and design applications can be underlaid in our GIS mapping solutions, and then vice versa. You could take our mapping solutions and underlay them within the CAD system, overlay your design information on top of maps, create a more collaborative environment, more informed designs, et cetera. Over the last couple of decades, you've probably been well informed and kept up to date on the evolution of BIM, but in the world of GIS, I'm going to expect it's probably a little bit newer to you. We weren't necessarily in the BIM conversation in the earliest days when Autodesk and Revit and various other tools and companies were developing BIM software. We were a little bit late, I'll say, but we have made up for lost time. In the last decade, between the applications that we've developed, desktop and cloud-based, the extensions and the connections into the Autodesk suites, our ability to bring in Revit files directly, IFC files directly, underlay that information, like I said, into the CAD tools has been significant, and we have an ongoing basis of growing these capabilities. My role at Esri is the director of AEC industry. Esri serves virtually every industry that you could imagine, not just the infrastructure and the design construction space. We are very well known in logistics and retail, government agencies who require maps and logistics support are utilizing our software globally. My focus on the AEC space has been quite fun, like I said, at Esri, because I've come in at a time when the company has already dedicated significant effort into improving AEC workflows with GIS. Our flagship product is a tool called Arcgis Pro. It might be analogous, you might think, to like a Revit or an AutoCAD, a CAD or BIM product, a desktop tool with great connections to the cloud where you bring in information, you bring in your layers of data, you bring in maps, you bring in demographic information, you bring in your CAD and BIM info, and produce scenes. Perhaps the scenes are presented as maps, but I think you'll see through my next set of examples 3D environments that are interactive, immersive, and very rich. There's a product that we've come out with recently in collaboration with Autodesk called Arcgis Geo Bim, which directly connects the Esri cloud and the Autodesk cloud, allowing those collaborative environments, the underlaying, like I said, of the maps in your CAD and BIM world, or overlaying your CAD and BIM information into GIS space through a cloud-to-cloud connection. So let me just kind of jump in here a little bit about location. As I mentioned at the start here, how important location is in AEC. The projects that you work on, the projects you're involved with are spatial, not special. Maybe they are special, but they're spatial. And yet, I would say that the majority of AEC tools don't necessarily take into account location and its importance. I think it's also quite interesting, when you look at the many industries across the world, AEC, architecture, engineering, construction, the work that we do is perhaps the most complex from the perspective of the many types of information that have to be brought together. CAD and BIM information is some of the most complex data that is worked with. Overlay on top of that point clouds and various other reality captures. Bring into information about your context, your traffic flows, your weather patterns, your loads of people coming in and out of buildings, spreadsheets, Word docs, PDF files, all being brought together and needing to be analyzed. I really don't think there's an industry as complex as ours as it pertains to all the types of information that have to be brought together. And what's interesting is that location is an integrator. Location is a common denominator of all these bits of information that need to be considered for planning, designing, construction, and operations. And when you consider that location can bring data together, that is the start of new ways of working. You bring data together, it allows people to work together. And I've seen this myself through numerous examples of our customers who talk about previous examples where they would produce their own data, throw it over the wall to their consultants, throw it over the wall to other participants in their projects, but not necessarily be connected to those other people. But when the data is connected, when applications are connected, people end up connecting. And when people end up connecting, it enables digital transformation. It enables people to have new types of conversations. Conversations about workflows that they really want to make happen but haven't been able to. But when the data is connecting, when solutions are integrated, people are working together better, and that's enabling digital transformation. And digital transformation, you might actually rephrase that as business transformation. These days, if you are not digitally transforming your AEC business, you're probably not going to be in business long. Your business has been transformed through technology. It's going to continue to be transformed through technology, but it's critical for people to be connected for this to happen. So how does Esri take this concept of location? How do we go to market? How do we influence projects? We see kind of three areas from the AEC perspective that our tools are critical. And first one about environmental management. Often the very first part of any kind of AEC project is understanding the environment that the project exists within, its context, the impact of any new construction, or perhaps a historical project that needs to be remediated. And with a geographic approach, considering location for these projects, it allows the professionals who do this work, environmental managers, environmental consultants, to do a better job of saving water, reducing materials, minimizing the impact, reducing energy consumption for the projects that they get involved with. So our tools are used for those earliest stages of environmental planning and permitting. Our software is used in conjunction with CAD and BIM tools for the assessment, the remediation, and the restoration of environmentally sensitive projects. Environmental construction, sort of its own world unto itself. Esri tools are very often used to understand the impact of construction for these environmental projects, and certainly the reporting. It's critical that environmental projects that have an environmental component, are reported on in consistent ways. Often government agencies have very strict methods on which one must report the progress for projects that have an environmental impact. And our tools and software and systems over the years have evolved to be able to deliver those reports in the ways that environmental projects are required. So just a series of a few vignettes here and examples. These are all sped up. These were, in some cases, 30-minute demos that I squeezed down to 1 or 2 minutes. This is the city-state country of Grenada, who have completely captured the entire island virtually. They've used GIS to not just visualize, but to analyze the information. So here you're seeing the entire island. As we zoom around, you can see buildings popping up in 3D. You can see the effects of ocean rises. You can see the watersheds. You can zoom in and understand the buildings themselves, how they relate to each other, how they relate to the watersheds, how they relate to the island. And this is more than just a pretty visual. Every one of these buildings that you're seeing here actually have data and attributes behind them. So the entire island has been built out as a digital twin for environmental analysis, environmental simulation, and all of the BIM capabilities you'd expect. Another project here with an environmental component to it is in Dubai, a solar farm that is actually feeding and is the energy supply for a desalination plant. So a combination of 2D and 3D, typical maps as you'd expect from a company like GIS, but BIM-like views as well. And these model objects are, in this case, visualized and described specifically in Esri. Other solutions that we have combine Esri tools, GIS environments with 3D content that came from Revit. In this case, this was, I believe, in Taipei, a project that from the US, we coordinated the reality capture. And then in Taipei, they used the models and brought in their Revit content overlaid on top of the GIS, visualized with the point clouds to understand the environmental impact of a new project that they were going to build and whether or not potential ocean rise would affect this new design for a project on one of the ports. Another area that Esri focuses on around AEC specifically is design and engineering. You know, this is kind of the core, the place where you perhaps first think about AEC work. It's the heads down, fingers on the keyboard, producing the drawings, producing the models, producing the documents so that our world can be built. And GIS serves great value in these workflows, allowing the designers, the engineers, the planners to have context, to understand their environment, not just their building, not just their road, but the environment in which that building or that road might exist. Using GIS in conjunction with BIM in design and engineering delivers better documents, better models, better insights, better processes. So as it pertains to design and engineering, I'd say that our tools are used, you know, certainly in these workflows, but really across the entire spectrum of design and engineering tasks. I think we first are used in planning and design because, again, that context. One of the scariest things I recall being in an architect and engineer professionally is that blank screen, starting out without context, having to put the first line down, whether it's digital or with a pencil. But understanding context, knowing the environment, knowing traffic flows, weather patterns, knowing the environmental conditions of your project certainly help in those first stages of planning and design. GIS tools, I think you'll see through some of the examples that I'll show, is a brilliant solution for collaboration. You know, getting out of your mind's eye what your design concept is and helping your entire team understand what you're working on and being able to collaborate around information is what leads to successful design and engineering projects. And not everyone is going to have a copy of Revit or a BIM tool on their desktop, but they need access to that information. And GIS is democratizing that, getting that information into the hands of the entire group of stakeholders who might be involved in projects. You'll also see through some of these examples how our tools are used in field-based workflows. And design and engineering very often happens at a desk, in an office, or these days, I guess, perhaps at our kitchen table, but much of the work still happens out in the field. You'll see through some of our examples here Esri's tools used for form-based work, reality capture, scanning and analysis of point clouds and meshes. And then certainly that all applies to the as-built-in workflows as well. So this first example here, this is using a product of Esri's called City Engine, which is a parametric city and building modeler, where all this data is brought from Esri through our SDK into an Unreal environment. So in real time, this level of visualization and models and interaction running on, in this case, I think this was actually a desktop application, was used to inform the city planners what their town might look like with a 3-story set of buildings versus the 2-story set of buildings. Various awning and building front styles versus others. So you can see at the bottom there's scenario A versus scenario B. This is a completely data-driven environment. So this isn't like a 3D studio scene or a typical gaming scene, which is static. This is dynamically generated models. And again, every so often you'll see scenario A versus scenario B happen, where the buildings themselves completely change designs by tapping into the GIS data and parametrically running the scenarios. This animation, there we go. This is actually downtown Denver. I didn't realize it until it zoomed out. This was an example that one of our solution engineers put together. And you can see a combination of 3D meshes that were generated from flyovers. You'll see certainly GIS type information helping you understand sort of zoning and routing and usage of various assets within the city. But then also in this environment, we bring in a Revit model. And that Revit model is just imported directly. We have a great relationship and partnership with Autodesk that has allowed us to directly read and write out and integrate with Autodesk solutions, as I mentioned earlier. So in this case, we've got a BIM model that's going to pop up on top of an open site. I think it was a parking lot, where we're going to analyze that BIM information in context to the city itself. Daylighting analysis, flow analysis, etc. This is an example of that Geo Bim product that I mentioned early on, one of our connections with Esri, with Autodesk, where what you're seeing is an Esri environment combined with an Autodesk environment. One single browser tab here running with a map on the left, a 3D map, where we click on an air handling unit on top of the building that connects us to the Autodesk Construction Cloud, which houses all the additional information, all the CAD information, all the details that you probably wouldn't want to keep in a GIS. There's information that you want in GIS, and there's information you want in your CAD and BIM environments. You know, the term common data environment has been bounced around a lot lately over the last few years. At Esri, we talk about a connected data environment. We're not under the impression that every bit of information is ever going to be stored in an Esri world, or an Autodesk world, or an SAP world, or a SharePoint world. We exist in a connected data environment. And ArcGIS Geo Bim, what you're seeing on screen, is exactly that. A combination of the GIS world, and in this case, the CAD and BIM world, all the data hosted by Autodesk. This is an interesting project. This one is in Taiwan, I believe. Hopefully it starts playing. There we go. Here, I believe about 20 kilometers of light rail with various stations, train stations, designed in Revit, brought in to Esri, where we can visualize the context in various types of environments. So a rather simple schematic-like view with the BIM models, highly articulated, zooming around the entire city with tremendous speed. This one actually is not sped up. This was a scene that I actually interacted with and just recorded the screen itself. But you can see 3D models that came from BIM environments overlaid on top of data that is essentially OpenStreets data, 3D content that's open source, available to be brought into GIS. Where again, we can do sunlight studies, we can do flow analysis, we understand the context much better than we would just in a basic CAD or BIM world. And this is an interesting project as well. This is from Arcgis, the AE firm based out of France. Here in Paris, they did an analysis of their various train stations, their population centers, their population density, to understand where and how they should expand their train stations. So this was a Gare du Nord Revit model, again, brought into a GIS environment where you can understand not just above ground, but underground. Understand the tubes, understand the egress, understand the movement of people and space through the spaces themselves in this GIS environment. Zoom back out, and you can see then what the impact would be of this particular train station on population. So with that, with a little bit of understanding of who Esri is, what we do, some of our examples, I'm going to hand it over to my friend and longtime colleague, co-worker at one point, I guess, Paul Doherty.